All right, so short video today, moles, molecules, grams. These will be two-step problems. We're either going to go from representative particles to grams or go from grams to representative particles. And so the first step of any problem will be picking your conversion factor. And it's either going to be moles on top and Avogadro's number at the bottom, or vice versa. And the same thing for the second step will be either moles on top and molar mass at the bottom. And you'll see the demonstrations, but we're going to use these same conversion factors. So the first problem is, how many molecules are there in 45.6 grams of sodium oxide? And how many grams are there in 5.67 times 10 to the 22nd molecules of water? Do them now.
All right, so we have 45.6 grams of Na2O, and we want to find out how many molecules there are. Probably formula units would be better since it's ionic, but the steps are, right, is anytime I have a mass, and I'm talking about mass, I want to find molar mass. So first step is to find the molar mass of sodium oxide. So I got Na, and I got O. Na, I'm trying to use your same periodic table, as 22.990. And there's two of those. And O is 15.999. All right? So, math, 22.990 times 2 is 45.98. And there's only one oxygen, so times 1 plus 15.997, that'll be a 0. So I take 45.98 plus 15.997, 61.977 grams per mole of Na2O. So now I have the molar mass. So I start with grams here. Again, I want grams down here, so this number goes with grams. 61.977 grams of Na2O and 1 mole of Na2O. Grams cancels. Now I want to go from moles to molecules, and I know 1 mole is 6.02 times 10 to the 23rd molecules. So I have moles here, so I go 1 mole of Na2O down here, and I go 6.02 times 10 to the 23rd molecules of Na2O. And now I can solve. So when I solve this on my calculator, it's a two-step problem, but I type in 45.6. Since this is on the bottom, I'm going to divide that back, so divide by that, so divide by 61.977, hit equal. But don't do anything with that number, and then you look at the next one. It's on top, so I multiply. So I multiply by 6.02 E23, and I get for my final answer 4.429256 times 10 to the 23rd. I want 3 sig figs, so it should be 4.43 times 10 to the 23rd molecules Na2O. So we went from mass to molecules. Mass to molecules, divide by molar mass, multiply by Avogadro's number. Boom, we're there. Okay, now let's say we want to go the other direction. We want to go from molecules to mass. I have molecules here, so I want molecules down here. Avogadro's number always goes with those units of counting. So I got 6.02 times 10 to the 23rd molecules and 1 mole of water. Molecules of water, sorry, I didn't put it in there. It cancels. So I'm at moles. Now I want to go from moles to mass. So it's molar mass. So I got to find the molar mass of water. H2O, hydrogen and oxygen. Hydrogen's molar mass, my markers are slowly dying on me. Hydrogen's molar mass is 1.008. But I multiply by 2 because there's 2 hydrogens in water. Oxygen is 15.999. There's one of those times 1. That's 18.999, and this is 2.016. Add these up, 5, 9, 10, 11, 1, 9, 10. This is going to be 18.015, and that's that many grams per mole of water. So now this is my molar mass of water. I have 1 mole up here, so I put moles down here, and 1 mole of water. I have 18.015 grams of water. Moles cancels. I have my mass number here. So put in the calculator. 5.67 times 10 to the 22nd divided by Avogadro's number, 6.02 times 10 to the 23rd, get an answer. And then since this is on top, I'm going to multiply that answer by the molar mass of water, 18.015, and I get an answer of, and I want 3 sig figs, 1.70 grams of water. Please, please, please put these into your calculator to make sure you can get the same answers as I. So as you work on the assignment, you're not going to make any mistakes with calculators, okay? Nothing worse than getting it set up properly and be right, but can't get the calculator to work. And again, if you have questions, shoot them my way.